When you are converting from pieces or formula units or molecules or atoms, and you want to get the number of moles of those things. So if we're going in this direction, we're going from pieces to moles. What you're going to do is you're going to divide this huge number of things, like a number of atoms, by Avogadro's number, Na. And remember, Avogadro's number is 6.02 times 10 to the 23rd pieces per mole. So imagine I have pieces of some kind, and when I divide by Avogadro's number, it's going to look like this. Pieces. And remember, pieces could be formula units, could be molecules, could be atoms. And there's 6.02 times 10 to the 23rd in 1 mole. And so when you do that, the pieces cancel, and what you have is moles, and that's what we were trying to do. Now, when you want to go from moles to mass, the conversion you're going to use is molar mass, and you're going to multiply. And you're going to multiply by molar mass. Now remember, molar mass has the units of grams per mole, and we get that by adding the masses of all the atoms in one molecule. And so if we have moles and we multiply by the molar mass, our units are going to be grams over moles. And the moles cancel, and then we have grams, and that was what we were after. And so let the units be your guide for the direction and what things you have to use. Notice, though, that you cannot go from pieces to moles. You can't go from pieces to grams without going through moles. You must use Avogadro's number. If you're going in the opposite direction, from grams to moles, then you're going to divide by molar mass. And if you're going from moles to pieces, think about it like if I have a dozen donuts and I want to know how many donuts I have, I'm going to multiply by 12. Well, if I have a certain number of moles and I want to know the number of atoms in that mole, I'm going to multiply by Avogadro's number. Here's an example where we're going to get the moles of a particular atom from a formula unit. So if I have, and this is really hold apart, if I have 2.45 moles of nickel phosphate, nickel 2-phosphate, which has a formula of Ni3PO4 2, I have 8 atoms of oxygen in every formula unit of nickel 2-phosphate. And so for every 1 mole of nickel 2-phosphate, I have 8 moles of oxygen. And the moles of the nickel phosphate will cancel, and then I have moles of oxygen. And that number comes out to be 19.6 moles of oxygen. And that is the answer to this question, moles of oxygen. But I could also ask, how many oxygen atoms? Now, I'm not talking about molecules of oxygen, I'm talking about oxygen in this compound. So I'm just going to use O, I'm not going to use O2. So I will start with 19.6 moles of oxygen, and I want to get the number of oxygen atoms. This is going between moles and atoms, and so I need to use Avogadro's number. And I want to get rid of moles, so I'm going to say 1 mole of oxygen atoms is 6.02 times 10 to the 23rd oxygen atoms. And when I multiply those two numbers, I get 1.18 times 10 to the 25th atoms.